All right. So assalamu alaikum everyone, and welcome to another exciting virtual session with JackBD. Today we have a fantastic session lined up with our esteemed friend Shaaf. Large language model are, you know, among the hottest topic in technology right now. While many people associate LLMs primarily with Python, but there is immense potential within the Java ecosystem, and especially in the enterprise world. That's why today's talk, understanding large language model for Java developer, I think not only timely but also incredibly relevant. And I'm pretty confident you will find it both insightful and engaging. So before we dive into this session, allow me to introduce our speaker Shaaf. Shaaf is a principal architect at Red Hat and an active contributor to the Konveyor community. I don't know how it pronounced, but they probably, if I miss pronounce, please
Right.
correct me. It's an open source community for infrastructure stuff. For example, Kubernetes. I hope Shaf will let you know more about it. With over 15 years experience, he has been instrumental in helping customers design and adopt open source solution for application, cloud environments, managed services, continuous integration framework, and more. He primarily works with Java, Node.js, and recently AI and machine learning technologies. Additionally, Shaf is a technical editor at InfoQ, where he writes extensively on Kubernetes, security, and Java. As you can see, Shaf has a deep expertise and experience. So this makes him the perfect guide for this topic today. Um, so before I hand it over to Shaf, I want to encourage all of you to actively participate. Feel free to ask questions at any time. There is no such thing as a bad question. So feel free. It's pretty informal. So don't hesitate. Don't stop yourself asking questions. Please do ask as many questions as you can. We'll try definitely cover as many as we can. But and yeah, let's see if people already joined. I can open my YouTube. Just give a second. Um, so I see a lot of people's already joined. So drop a message in chat. What I don't know which platform are you watching from. It could be YouTube, LinkedIn, Twitter, Facebook. Um, So one thing I need to remind you, if you are commenting on Facebook, please include your name in your message. I don't know what happens to this streaming software, but it doesn't display the name. So yeah. And finally, don't leave early. We have a special announcement at the end of the session that you don't want to miss. All right. So without taking more time, it's my pleasure to welcome Shaf to the session. Assalamu alaikum, brother.
Wa alaikum assalam and salam to everyone. Thank you so much for inviting me. It's a pleasure and an honor. And I have prepared 200 slides for you, so we're gonna make sure. No, we probably go less slides and more code, hopefully. So, but very excited to talk about it. Like Basil also mentioned that. AI is hot. Everybody wants to talk about AI, so I'm really happy to engage and talk about this. So today's talk is going to be more about understanding Gen AI. So some part I will cover in the beginning, which is more about what Gen AI is, and maybe a little technical details, not too much. And then get into the some of the demos that we have, and you can see how you would build an application with Gen AI or large language models, as I would call them. And why is it so interesting for Java developers? Because everybody or most people think, oh, it's Python because you do machine learning in Python. So let's just assume that LLM or large language model integration will also be done with Python, but that's not true. There's LangChain out there as one of the community projects, and it's based on Python, but it also has a Node.js variant as well. And then there's another tool for Java, which is called LangChain for Java. And there's a couple more tools as well. So it's growing. The ecosystem is growing, and Java is a fantastic language, as we have mostly worked with. So at least I've worked with. So a bit of introduction on that. I started doing my Java development somewhere around 1995, right after my, well, I don't want to tell you my age, but let's say right out of my college. I took the Java book from O'Reilly and started to study it and understand it, and I failed miserably trying to understand what it was. But it was interesting, and it was a very nice way of me starting it. And so if you're familiar with Swing and AWT and all that kind of journey, I have been part of that journey as well. So that's just a quick introduction, and I have some of my social handles if you want to follow my blog post or write to me as well. So let's start with our topic, the interesting topic, the topic that everybody wants to hear, everybody wants to talk. Every application is going to have large language models integrated into it, and it's going to change everything, right? So that's the hype. That's what everybody wants. And as we have seen the hype cycles, every technology goes through it, and I think large language models is pretty much at the peak of it hike, right? So at some point it's going to come down, and people will start realizing it that what the actual value out of it is. But at this point, it's extremely high, but it's also the best time to learn, and that's exactly the reason why I want to delve into it with you today. So let's assume, like, okay, understanding the journey that actually brought these large language models or foundation models to us, right? So back in the days when I did the artificial intelligence neural network course, there was not much of what we call deep learning today, right? So there was more like there were expert systems. They were more like systems that we would try to create neural networks with. But then over a period of time, since then, like 90s, 2000, a bit late in 2000, I think, it started to change, and it changed with the company called DeepMind, and how they brought this whole concept of deep learning and supervised learning, unsupervised learning, classification, all these different elements. So you could actually create systems with machine learning in a much, much more better way, and provide many use cases and values from there on. But the last 18 months or so, we have seen, the explosion of foundational models or large language models. And this is not something extremely new. I mean, there's GPT-2, then there was GPT-3, and then there's more. There's also the Llama stack. There's also IBM has its Granite stack. All of these different, variations of large language models exist in the open source as well as. But we know that OpenAI and ChatGPT probably everybody's heard about, because that's probably the one that everybody was amused by as soon as GPT-3 came out. It does a lot of learning with without labeling, without actually intensive adaptive tuning, etc. But it has a lot of data that it churns and takes and starts with. For example, I believe it's GPT-3 was about 300 billion tokens or something like that, right? So it's a lot of words, it's a lot of text, it's a lot of things out in the web that actually creates this large language models. And depending on the amount of parameters, etc., they become bigger and bigger, and they can answer more questions. So they have a lot of domain. It's not just one specific domain. Whereas if you look at deep learning models, specifically, we are trying to solve a certain problem in a certain context. But with large language models, there's a lot of information out there. And obviously, both of them have goods and bads, or use cases, not goods and bad, but use cases where you can apply them, right? So let's take a look at large language models and where we stand with large language models. Large language models can do simple things like it can translate text, it can summarize text, it can do writing. So if you ask to write, a poem or a story, it's very good at it. It's good for question and answers. So that's one of the interesting things. You can do some sort of reasoning with it as well. You can ask for more information, get into things, and it's a very interesting experience when you're learning something. It comes from something called a paper called what we call the transformer architecture, mostly in the industry, but the paper itself was in about 2017. Attention is all you need, and that's where they explain how the transformer architecture works. It's quite simple. If you get into more details, it's more like natural language processing and translation. So let's say if you wanted to convert something from of one language to another, so let's say converting a German language to English, or and so on forth, there is some context within the language as well, and there's this language processing that you need to do in order to transform that. So something like a transformer architecture is an interesting way to address that. But once you start churning more data into it, it also has a lot more applications as well. So it can recognize things, it can do some sort of predictions, and it can generate a lot of text as well. And we'll see a little bit about how it actually does some of that prediction as well. The big models have been trained on billions of words. You might have heard the term interchangeable, like tokens and words. They sort of like are similar, and there's a bit difference. When we get to the next slide, I'll explain that. But to make it simpler, it's actually words. So take the entire wiki data, or the data on the web. All of that is textual data in words, as an example. So these models, they are trained on those words. And very, very important, I'm not saying that it's trained on a document or trained on a sentence. I'm saying words. And that's specifically a reason why I'm saying that, because that's exactly what forms the core context of how large language models operate. Another interesting thing is that, and we'll speak a bit about it as well in this presentation, and hopefully after demo as well, is that yes, you can have trained data, but as an organization, if you're working at a customer or within your own organization, the data that exists in your organization is not in ChatGPT, and neither should it be. It might have IP, it might have security attached to it. You need to protect that, all of that. So there are models out there that you can use, and you can train them. The foundational large language models, you can train on top of that with your data, and then you can have a large language model which is internal to your organization as well. So they can be tuned further, and can be made use of in specific scenarios as well. Fine tuning is not a topic of today's discussions, but happy to take questions and happy to delve into further if we need to. So what does a large language model do? It actually predicts the next token. And token is sort of, you could say, is like a word. And what it does is that when it's trained all this data, and there's a lot of technique on how it's actually trained, there are ways of doing it, it predicts the next token. So it's more like a statistical deduction of what exactly it needs to do. And that statistical deduction is based on how the people who train that data into the model have laid it out. So you will see differences in large language models. Some large language models will give you a lot of information for a most basic question, right? And some will give less. And that's a very simple differentiation. And in that case, that is how the actual foundational model was trained, right? So there are different algorithms to train them. There are different ways to do it. And one of the core things that's out there is the token. So let's take a look at what a token is, right? And tokenization is like breaking down text into tokens. And we, Java developers, we know this very well. There's string tokens, right? And we've used them so many times in so many places and use cases. There are two algorithms like byte pair encoding and word piece, and not going into much of detail, but they handle the different ways of tokenizing. So an example on the slide here says, Quarkus is great, and these are three different words that are in there in this word-based token. And then there's another one which is Quarkus is great, but this is like a subword when you're using or attaching words to a sentence as an example, right? So why do we need tokens? I think you might be thinking right now, like, okay, this is interesting, but why do we really need these tokens, right? They sort of form this basis, but once you start to use the tokens, those tokens are then converted into this mathematical value. And that mathematical value is then laid up on each other, and kind of create this logic and this sense of how the algorithm should predict the outcome of what comes out of the large language model. Now here on the left at the bottom of the screen, you'll see that there's a lot of text. It has 53 tokens, and 53 tokens, 252 characters. but not all words are tokens. Tokens can be different. Tokens can also be an end of line token. Token can also be a special Unicode character token as well. So it is the way how the encoding and decoding algorithm uses that tokenization that matters. So do not get confused when you use large language models that, okay, this token count does not seem correct. The reason is because the token count could be different based on how it's actually being read in this situation as well. But what is important is that all of these large language models have token limits, and they will say, okay, like if you're using something like a llama, llama stack or something like that, and or llama 3 as an example, and you could set the max number of tokens that you want to send or receive as an example. So in that case, you could say, okay, I have tokens, but tokens are not just words, but they're also special characters, spaces, etc. So you need to sort of have an idea on what that is. On the right here, you have the mathematical representation of those tokens. Now, tokens, obviously, we don't see tokens when we speak to a large language model, which means that we have, we are putting text, it's converted, it goes into the system, into the large language model, and it processes it. It creates the right kind of combination of what it needs to process and spit out. And once it comes out, it's decoded as well, right? So the question might occur like, okay, what is this? Like, why do we need to do this? Why doesn't it just store it in English, right? It is because if you look at some of those large language models out there, they have layers of how these mathematical numbers are layered together. So for example, on the right top corner here, on my presentation, you'll see that, and this is from a book called Building Large Language Models from Scratch. If you are interested in building a large language model yourself to learn, it's an awesome book by Manning, and the author is Sebastian Raschka. And in his picture here, he kind of shows that, okay, vector embeddings of different types of birds as an example. So eagle, duck, goose, and then vector embeddings of the word squirrel. And you can see that all these different vectors that are created would have multiple layers and multiple dimensions to this, and we're just looking at this in 2 dimensions, right? So the layers could be up to 15, 16, and even more layers to actually process and create those connections between them. Complexity, it's a more tuning kind of a thing, so I'm not going to waste more time on this, and let's move on to the next. But tokens are interesting. This is how we work from our Java code, from when we send in the request, so it's important to know what tokens are. But funny things also happen. They are amazing things that's technological advancement, but it can make stupid mistakes as well. Like, so for example, if you haven't noticed, this the picture has all the 5 fingers in the hand, right? No, actually 4. So maybe the token representation was mismatched here as an example, or there was something else, right? So it is when we start, kind of confusing accuracy with truth. So there are 2 different things, and should we confuse them? And when you're using a large language model, you need to remember that it is this prediction of tokens that goes on, and that's how the answers are deducted. And you need to be careful about how accurate it is and how truthful it is as well. It might be accurate, but it might not be true, right? The other important part of also while developing applications is that you need to remember is that truth is discrete and it's not continuous, right? So for example, take an example of a doctor. A doctor, sees 10,000 patients, and out of that, and critical patients, maybe 1,000, let's say, right? And his success ratio could be that he saved 900 lives of patients, as an example, just a rudimentary example here, but that he saved 900 lives. And if he saved 900 lives, could he have saved 900 and a half lives? That's not correct. So truth is specific, it's discrete, it's not continuous, it's not changing. And with large language models, there can be situations where there is hallucination, where the data is not represented correctly. So those are some of the challenges that you would face when you're creating that, and you need to keep that in mind. it's awesome, but it can also harm you in some cases. So if you're not careful, you can a large language model can have multiple things. And here's an ATAQ, representation of data that they did like a test. And in this test, when they look at the different areas of large language models, they're able to see, okay, there's explicit content in large language models. Obviously, when they have loaded the entire world into their model, there will be things, there will be biases, there's going to be things about substance abuse. You could go in and say, could you give me a recipe of XYZ, and it might be harmful and it's going to give you that. There's also deception and so many other things. So GPT-4, when it came out, it would exploit 87% of one-day vulnerabilities, right? So you don't want that either when you're using public models with your application, or you're using models internally, that you based your you tuned your data on top of a model. You don't want that your users or your chatbots or any application scenario where a user could just do a prompt injection and actually provide or get explicit content out of it as well. So you need to be careful of this aspect of large language models as well. Finally, knowledge and skills. I mean, that's also one of the biggest obstacles. It's great that you can use it, but there's a lot of difficulty in using large language models or artificial intelligence in general, because people do not have the skills to use them or secure them, or so there's tons of these skills that are required in the industry as well. Productivity, obviously, does it make you productive? If you are using things like IDEs that have large language models in it, does it give you the exact answers that you need? Sometimes yes, sometimes not. There's some studies out there which say that generating code through large language models can be insecure and can be unproductive as well. So there are tons of things, but something also to watch out for when working with large language models as well. So coming to some of the interesting facts as we dive into the end of the first half of this session, and then we dive into some code. When you are looking at working with large language models, how would you address it, right? So if you are doing a simple thing like you want to get something, you want to send something to the large language model, get the output from it as well. So it could be even code generation, it could be XML to YAML, whatever you would want, right? So simple use cases. All you're doing is sending a request and getting one back, right? Response back. So that's post-processing, a simple way of doing it. Then you have something like RAG, which provides different examples of prompts. You have context, you can propagate that context, you can create that context within your client, and you can send that information. So you could send an information to this, like we do in one of our projects called Konveyor AI. And Konveyor AI is a modernization tool. So it takes old Java code, does some static code analysis on it, and then throws it into the large language model, and you can change it. So you can change like an old JMS code into reactive messaging, using asynchronous APIs, etc., all of that as well. So what we do in that case is we take all the static code analysis, we create some context, we send it into the large language model, and we know exactly what we want to deduct out of that response as well. So RAG is also an interesting approach where the large language model will take the data that it already has and use your context to define what the output is going to be like. And we're going to see that in the demo as well in a little while. Then there is PFT, we're using vector prompt. There's also instruction tuning. So instruction tuning is more like you are adjusting the weights. So each large language model has its own weights, the way it is trained. You can change the behavior of the model. You can make it much more smaller. You can make it lean into a certain direction. So let's say that it also answers on a specific domain always, and this could be more for small models. And then there's also other ways of custom training, which needs, let's say, tens of gigabytes of data that flows in and out throughout as well. And then finally, there's also, you can create your own foundation model. But as you see from right to left, the amount of data, the amount of complexity just grows, and it's hard to do. And you could create an application starting from just simple prompts, one-to-one. You can go into RAG, but then you might realize that you need data that you cannot even fit into RAG, as an example. And that's where you'd start looking at all the options on the left at this point. Finally, let's do this, is that infuse AI into my world. And for that, there's a lot of systems and applications out there. If you're familiar with Java EE applications, that have been running for years, 10, 15 years, old legacy applications that are out there, they host a lot of data and they have so much of knowledge in them. So why could we not use them? And why could we not use Java, the language that we love and the language that has been used in these systems, to be able to actually create this interesting infusing of AI with Java? And that's what I will hopefully give you by the end of the session, inspiration enough to actually do this as well. When you look at a specific stack of how an application or what the landscape is, it's important for me to give you a little bit of information, not to go too much in detail. Happy to take the questions too, but I think I'm just going to lay out a bit of basics here. You're looking at an AI workload support that is mostly your base model, alignment tuning, hardware acceleration, GPUs, etc. So that's what you would see in an organization. Then you would see a platform that sits on top that's going to give you all the tools and libraries to make value out of your models as well. So training them, doing resource management, etc., etc. And then there's going to be a bunch of enablement portfolio that actually gives you usability, code generation, virtual assistants, these kinds of apps that you can use within the same context as well. But the more you go here on the left, you get into this infusing part. And here you are looking at, how can I connect my applications using the things on the right, for example, the platform, the workload support, etc. So hosting a large language model internally, having a model registry, all these things, and then working with your app to actually use them as well, right? So that's where the AI infusation comes in as well. And then finally, on the left, that's where you actually give the developers and others to be able to work with your apps using the APIs or over-the-top services or connectivity, etc. So if it's about remediation, if it's about, not hopefully about a booking system, but maybe, and you have APIs that will work with your AI to actually do that. And there are multiple use cases, right? Of generation, of integration with backend data, etc. So using all of that to create something of value as well. So that's how I would lay out a stack. And on the left is what we are looking at, the infusation of the AI apps into our Java. So here I'll break a second and I'm going to ask if there's any questions. I believe there is probably some questions that I need to answer. So yeah, please tell me, Belzer, if there's a question.
Oh, sorry. I was speaking, but I was mute.
Yeah.
All right. So the one question particularly related to what you have just said, I'm just reiterating the question. Basically, what he says is, as we are speaking of LLMs, we are speaking of volumes in billions for hosting and running those models in sandbox environment. So basically, he's asking how much power do we need if I want to run those in a sandbox environment, maybe for testing or something like that.
Yeah, that's a that's a very good question. So you can run. There's multiple options. You can run a large language model on your machine. There are multiple variants of a model. So if you look at Llama, you would see that, or Mistral, or some of these others, you will see there's a 7B, there is maybe a 13B, a 70B, and these are the billions of parameters that they are trained on. So, excuse me. So those billions of parameters also demand resources underneath. So the smaller the model size, you can run on your machine as well. So you can run Mistral, I think it's 8B, 8B quantized. So quantized is a little bit more smaller for your memory. I can run it on my machine. I have 3 GPUs, but anyways, even if you have lesser GPUs, you will be able to do that. Some of these models, especially in my experience, I've seen quantized ones. Some of these are really good at code generation. So I have this tool called Podman Desktop, and Podman Desktop has this AI extension. The AI extensions helps you to just load. There's another tool called Yanni. I've also used as well. Quite simple. Famous tools are LM Studio, etc., that you can use, or Olama, and they will help you to even do processing on your CPU as well. So for developer workloads, you can run them in a nice environment within your own laptop as well. When you go into the into actual, the bigger ones, then you can host them on GPUs, and obviously GPUs have cost. When you're going to host them, you can host them in a container as well on top of platforms like Kubernetes. So that's also possible. The more GPU the more GPU you will give it, the more faster response you will get. The more lesser it is, it can tweak. So depending on different models, you can choose to answer your question. You can choose different models that are smaller of size that you can run on your machine. Sorry, I think I took a long answer, but hopefully that makes sense.
All right. There's I think comments or questions from the. Let me show that questions over here. Mostly Python has all the library for this LLMs and machine learning. Is there any library for Java too? Well, that's why we're here today.
That is true. That's exactly why I'm here. So Python obviously has training libraries, right? So whether it's PyTorch or when you're talking about TensorFlow, etc. So Python has libraries that you can train large language models, etc. But when you need to work with a large language model, you're basically just using a REST API in the backend, and all this LangChain and all of these tools, they are all created on top of it, and it effectively are just doing request and response in the backend. So it is not. I think Java is awesome for this because we have a lot to offer, multi-threading, etc. All these things. If you love the way Java model is in terms of programming and convention, you'll find that it's much more nicer to create. And then also think of it like this: is that a lot of applications, business critical applications, are written in Java, and so it's great to kind of extend to that as well.
Okay, so maybe I can take one more questions, and then we go to the demo. Then we'll take rest of the question later. So this question is basically, I think it's a beginner friendly question. So the question is, as a backend engineer, how can I dive into the space of machine learning space? So if you have any recommendations or suggestions for those who are starting the journey.
Yeah, so I was planning to give an entire talk on it, right? So so I'm a backend engineer, or used to be, and I got into fine tuning earlier this year. I took some courses before just to refresh myself on neural networks, especially on Coursera. From not that I'm promoting them, it's just that my experience I can share here. So there's some courses from Stanford that are very good that talk about supervised learning, unsupervised learning, and classification. So you kind of get a bit of hang of it, but they're not enough for you. Then there are tools like Llama Factory or Unsloth, or where I am employed, Red Hat. We have something called InstructLab that actually helps you to take a large language model and tune on top of it, right? So do fine tuning, or alignment tuning as it's called, as well. And then through that, I think InstructLab is awesome because it's very simple to create Q&A pairs that you can add. And I can throw in the chat later as well one of the Q&A pairs that I've done that you can try out as well. And then that Q&A pair is run through this whole process of data generation synthetically. And then there's a whole process of tuning it as well, right? So you can do that. You can use Llama Factory if you choose as well. There are Jupyter notebooks that run on Google, I think T2 machines, that you can use Llama Factory directly on their GitHub repo. You have the link for it. So these kind of things will get you into it. But then if you want to get into the weeds of it, then the book by Sebastian Jaschke, that's a really good book to get started and understand how this all works. So multiple directions you can go into.
Thank you for concise answer. So let's go to the demo, and we'll take care of the rest of the questions once we finish the demo.
Cool. Let's do that. So for here, I have a very, very simple Java application. If you have used JBang, JBang is a CLI tool. It helps you to run Java like you were running any other script. So here I have a file, which is a simple file called jokes.java. What I'm doing in here is that I drag in the dependencies. So this is not the Maven dependency style that you're familiar with. It's quite close, right? So what it's doing is that it's dragging these artifacts up from Maven repo. And then these are some configurations. I'm using Quarkus. So Quarkus is one of the frameworks, if you're not familiar, to create Java code as well, just like you would do in Spring. It also has all these nice cloud native stuff and integration with Graal VM and all those. It's fast. It's probably the fastest, I think. And it's quite amazing. So JBang uses that. In this example, I'm using it. Then what I'm doing is I'm using something called chat language model, which is the LangChain for J. So LangChain for J, I will give some details in the end of this demo as well, but I want to dive into code. So, but just quick reference, LangChain for J is a library that is specifically written to work with large language models, right? And like I said before, large language models, when you are working with them in this fashion, they're basically using an API at the backend, and LangChain for J integrates with that API. It integrates with all the other large language models, whether you're using Google Gemini, whether you're using Amazon Bedrock, or you're using Llama, etc. All of these different OpenAI. In our case today, I'm using OpenAI, right? So that's easier and simpler for me since I've been using it. But you can use almost any other large language model. I'm also using Pico CLI here just to give it some fun. But I wrote this code, and basically what it's doing is that I'm injecting the chat language model as an AI, so generate something simple. And here I'm just saying, tell me a joke about snow in Denmark. Now the funny thing is that it doesn't snow a lot in Denmark. Well, it does snow a lot in Denmark, but maybe not in Copenhagen. So I am living in Copenhagen, so that's where I start the joke from. So let's say if I say, give me a joke. It's gonna do this. It's gonna take this text. It's gonna send it out to the OpenAI backend, to ChatGPT, and it's gonna say, "Hey, give me a joke," right? And then it says, "Okay, why did the snowman apply for a job in Denmark? Because he heard the work conditions were chill." So that's a nice one. So it basically just is a simple request and response, right? So maybe I'm gonna try something different. Tell me a joke about food. And so this is just very, I'm just doing it fresh, so please don't mind it. This is ChatGPT answering here, so hopefully it's something nice. And you go JBang jokes Java again, and now it's just going to run the script, do the same thing, go back into the OpenAI and get something. So why did the rice go to school in Bangladesh? Okay. Because it wanted to become a little biryani kid. Oh, I don't mind that. I love biryani. So amazing, right? So this is very simple. It's just a request and response. And if I go back to my presentation here, then what's happening is that you could put that in your app, and what it does is that it creates this prompt, it sends to the large language model. And then it comes back with a simple response. So this is a very basic way of doing it. And obviously in Java or any other language, this is very easy. I could just type that in a CLI, and that would work as well. But what about let's do something more interesting. So if I take, for example, here an email example. And here what I've done is that I've created now two different prompts. And this is where we're going to get into a bit more detail. So in the first example, we just said, okay, create me a joke and it came back. But now what I want in this situation is I want the LLM to say, okay, you are a professional poet. Now I'm actually giving a role to the generation that's going to happen, rather than just saying, give me what you have. I'm actually telling it what to do. And you might have seen this in these demos on YouTube, etc., on ChatGPT, where people go and tell ChatGPT what it should do. So I could say it's a poet, I could say it's an artist, I could say professional poet, it's a programmer, whatever. And then what I'm saying is that this is my prompt, and my prompt here again is write a single poem about a topic. The poem should be lines. I can give the number of lines. So these are coming in from my API, and then what they should include in the poem as an example. So let's go ahead. I'm going to start this, and this will make more sense. And I do something called MVN Quarkus dev. And what this does is that this initiates the Quarkus dev mode, right? And what the Quarkus dev mode is going to do is it's going to bring this application up on my local backend. You can see it's quite fast. It's already started. If I go back here to my presentation and go into localhost 8080, I will see that my poem is here. In the Quarkus, if I just give you a quick introduction of Quarkus here, it has loaded some of these backend services, and you can see that it's using LangChain4j and LangChain4j OpenAI as well. The extension. So LangChain4j as the main component, but then OpenAI extension, because I'm using the OpenAI large language model as well. So let me just go here and go back here, and I say, email me a poem. And you'll see here that it's going to work. It's going to go back, and it says, in Denmark skies where clouds rise, blah, blah, blah. Not the most interesting of the poems, but yes, there are about 5 to 10 of them, right? Lines here for it as an example. What's happening is that I have hard coded that into my UI that I need a topic which is specific about Denmark here, and then these are the number of lines that I need. What happens in this particular case is that I have actually broken down the way I have developed this application. So if I go back in my presentation here, and let me do this, presenter view. This makes it easier. So here, the same sort of prompt that we had now broken it down into a system prompt and a user prompt. So giving it a profile and what a user prompt would look like. So rather than just a free-flowing text that we would put in the application, now we put that text as a template where we can actually say, okay, this is the topic that I want for, and this is the number of lines, for example. So we can even stop the generations at a certain point as well. So that's definitely making it more interesting, right? And something that this is provided by the LangChain4j. Something that here also is that you see that I'm writing something called an AI service. An AI service is part of the Quarkus LangChain4j extension. But what an AI service does is that it can inject these prompts, and it can connect with LangChain4j directly using the LangChain4j AI service in the backend as well. So it gives me this possibility to define this nice interface, and then finally I can actually provide this. But what I'm also doing in my backend is that I have also written something called email a poem service, and this what it's doing is that it's going to take the poem, and it's going to basically send it as an email. So whether in Denmark, we could say beautiful greenery, I guess, in Bangladesh. Let's hope it's nice. You need to correct me, Bowser, if I'm actually writing something which is wrong. And here I say 8 lines. I can say now I want 5 lines instead, right? And if we go back here, and I do the same thing, you will see that it's gonna generate a poem for us, right? the verdant fields sway, where vibrant greens graze the day, and so on and so forth, right? And only five lines that it generates. So this is interesting. It does this, but how is this able to actually do all of this emailing? The part is that this, what we've done is we've introduced a new annotation called @tool. And what a tool does is that it's going to send an email. This tool specifically sends an email. So you have the AI service, you have the resource, which is basically just serving the REST resource. But then there's a service that is doing some sort of thing, which is, in this case, is sending an email. So if I go up here, I have a tool which is called the email service .class as an example. And this tool is being used once my prompt is actually in action. So it was not just about simply, just doing system prompt and user prompt. Now I also have the option that I have a system prompt, I have a user prompt, and once the generation is done, it is done in context of a tool which will send an email out. So imagine this, that you were developing a software. You might want to do something in the database. You might want to actually use your database to actually enhance that generation as well. So what tools are basically doing is, you have a context, you have some additional tool descriptions that you add to the context, you invoke that model. That's what we've done here. And then that model also invokes and computes and gives that information to your tool, right? So the email is then sent out, in this case, with a poem as well. So if I go here into my, let's say, I have an extension called the MailPit extension. And what the MailPit extension does is that it shows me the emails that is generated. So here's the last email that we generated, and this is part of Quarkus extension as well, right? So you can see that in the dev UI. This is not something that I've created, it's just default part of Quarkus. And you can actually see that, okay, this is the poem that is being sent to somebody called sendmealetter@quarkus.io. So what MailPit is doing is it's not sending the emails out. It's actually listening to all the emails as an SMTP, as a server for emails. And then it's basically just showing us email. So we don't have to spam everyone everywhere, right? And we can easily test our code to do that. I also have the option that I can just go and chat to the UI as well. So here you're a professional poet with a lot of humor. And that's the system prompt that's there. And I can say, okay, write me a nice poem about Java developers, right? And then this is also a way of testing. I could also stream this chat, etc. And you can see here that this doesn't have the 5-line limit that we had, for example, in our source code as well, right? So it's kind of like differentiates how you're using it. If you wanted to do something more, even more interesting and fancier, here's another example that I have, is that which does fraud detection use case, right? So there's a lot of things, but let's take a look. What I'm doing here is that I'm saying there's a bank and there's transactions, and in these transactions, there can also be fraudulent transactions as well, right? So if I want to basically see what the difference is, what these different customers are doing, what I'm doing is I'm loading up some data, I'm loading up some default customers, example, etc. And then I am actually going to put that into my system with all the details of their transactions, and the system is going to check whether they actually committed fraud or not. Now, this logic you would put into a rule system, etc., could be quite interesting, but we can also do this with something like a large language model. So let me just go ahead and do that as well. I'm going to run this. And if I say localhost 8080, and you will see that I have some endpoints here that I can call. So for example, I go on the amount endpoint. There should be nothing on the amount endpoint because it needs a specific, let me see. Yeah, amount, fraud amount slash amount slash customer ID. So let's just take that. Yeah. So here, if I do that, it's going to tell me whether the customer number one, now it's going back to the large language model. It's checking with all the transactions. It loads them, all these transactions into the context, and then says the sum of the transaction amount for customer one is this, and there is no fraud detected, right? So
Can you
basically,
please
this is just a
increase the
simple thing
font a
saying,
bit of the
oh,
browser?
yeah, is that
Yeah, okay.
better?
Thank you. Yes, it's better
Okay,
now.
sorry about that. So here you'll see that it just says, okay, that was the total amount, and that seems fair. But assuming that I want to do something different, is that I want to say distance, and this one is going to check the distance. And now again, it's calling the large language model with the transaction details. And what the large language model is going to check is what is the distance between these transactions. So here it says our system has detected transactions that occurred in cities that are significantly far apart within a short period of time. For your security, we kindly ask to contact the bank, right? So it knows that, for example, the city of Metz and Nice are at a great distance, and because of that, and that's the large language model that has given us this explanation that that they're far 500 kilometers apart. You couldn't be doing the transactions, for example, at the same time as well. So you can play with such use cases when you are doing large language models as well, with obviously with some more details. So let's jump into another use case, and I have a couple of these, so hopefully we'll make that in time, unless Bowser just takes the bell and stops me. But I'm going to try to finish this quick, right? So we've discussed system prompt, user prompt, tools as an example that we enhance. So in our fraud detection case, we have a tool. In our email case, we have a tool. And that kind of helps that. In the fraud detection case, the tool was a database, getting data from the database, from Hibernate Panache as an example. Here, what we're doing is that, what about, we have cases where we want to take a lot of data that we have and we want to make use of it. So there's a technique that has been quite famous recently, or in the last couple of months, is retrieval augmented generation, right? And what retrieval augmented generation is doing is it's giving you the option to make an entire ingestion of a lot of documents that you might have, store them into your vector database, by creating the vector IDs, values, and then using those vector values in context with the large language model. So here what it will do is that you will pass your input or context into the large language model. The large language model will be able to tell you where the answer lies within these documents, even though that those documents do not exist in a large language model. And that's a very important distinction, right? So there's a limit. Remember, we spoke about tokens. There's a limit to how many tokens you can put into a request into large language models. And that's exactly what you play with, is you kind of make them into vector embeddings so that the embeddings are much smaller, and then you can push those embeddings and kind of create a connection with those as well. And this is purely done as an approach where the data that you want to work on does not exist inside a large language model. Now, our previous fraud detection case, we did the same thing, but in this case, the data size will be a lot bigger, right? So let's go and take a look at that as well. Perfect. I have an exception. Well, good that it didn't stop my demo. So we're just going to go up again, and we're going to go into the chatbot example, right? And what I'll do is, my chatbot example is, I'm just going to bring that up. And as I bring my chatbot example up, it is a simple banking application, right? So what it's doing, okay, I need to probably do this. Reset. Let me, does this look fine to you, or should I actually make it bigger, the text? Maybe
Yeah,
this is
this looks good now, I think. Yeah.
big. Okay, so
Or make it a little bigger, because
there you
yeah.
go.
Yeah, okay.
So I have some questions. Which account do you offer, right? So It's going to give me a list of accounts. There's a secret account. There's all these different accounts that are out there, right? So basically, what this is doing is that it's taking all my information for this bank and putting it into the large language model, and this chatbot is answering my questions based on that information. Because if I go into the large language model and say, hey, do you have a market account, it's going to be like, what is a market account, right? So what's happening here is that in this specific example, I have a resources folder. In the resources folder, what I've done is that I have a lot of these, elite money, market account, retirement account, smart checking account, all these different information. And if you look at it, it's just text information, right? This text information does not exist in the large language model. So what I then do is that I do the ingestion of these documents by taking or loading up all the documents, like in this case from the resources. I am parsing those documents, and then I am throwing them out to get the embeddings for those documents as well. And basically, by doing this, throwing these embeddings into the context, I have the possibility that the large language model would be able to search through my domain as well. So if I remove this secret account over here, which I had basically from my previous demo should have removed anyways, but what it does is that now, if you look at it, there are 4 accounts here. And if I refresh my app here again, and I say, okay, which type of accounts do you offer? And say, okay, I offer 1, 2, 3, and 4 types of account. List the accounts provided. So you will see that it's going to list those accounts, right? So it's not listing, and that's interesting. It's actually giving me more details. So list only the headlines of the accounts. Right, let's see if that does that. Perfect. So it says that it has a secret account, right? So here you can see that even though I remove the secret account, it doesn't really pick that up, because in this specific demo, the ingestion has already been done, and I need to re-kick in that ingestion in order for it to actually work. So I could do that, but things like, for example, document splitting, embedding, all these other features that we have, these are being done manually. So if you were developing this, you would say, okay, how do I do this? How do I actually make sure that when I'm loading the documents, I'm splitting the documents, I'm generating the embeddings, I'm storing the embeddings? How is this all done? In our case, the vector store is a Redis vector store in the backend. The embeddings are being generated from OpenAI. The documents are being split. These are all using LangChain4j. So what you're really thinking is, what is my way to split my documents? Because it has to have some sort of logic. And that logic actually defines, when you provide the context, that the response you will get. If you don't provide that logic correctly, you will get a wrong response, because large language model is only using the data that you're providing. And if any of these items are incorrect, you're going to have a bit difficult problem. So it gets a bit complex. How do you want to split them? Do you want to split them as a document? Do you want to split them the entire chapter? Do you want to split them as a sentence? Do you want to tokenize them? How many tokens do you want to do? Do the segments overlap, because the data might be quite close to each other? All of these things, they become quite like difficult sometimes to kind of figure out what this is going to happen. How are you going to do this? So what we do here is, for example, is in Quarkus LangChain4j example, we have a way that we can actually do this, all of this, just by the defaults. Obviously, when you're developing an application and you have all the skills and understanding of all of these different elements, you can do the splitting. But if it's just general splitting and not too much more detail, you might want to do something that is much more simpler. So here, oops. Okay, seems like my IDE just okay. So I'm gonna go here and say localhost colon 8080. Awesome things happen all the time. Which accounts do you offer? Okay, so it does the same, but here what it's done is that it's okay, it's back. Perfect. Seems like my IntelliJ slept for a while. So we have something called EasyRag, and what EasyRag does is that in this case, like for example, the embeddings are there. You see that I am not doing the splitting anymore. I just have the WebSocket, and it's going to do all the splitting and everything by itself. I don't need to do that anymore. So the EasyRag will help you to kind of just take care of the basics that you have there as well. And that's very helpful, and that kind of makes sense. One final example that I also want to show you is, and I think I should have shown you that a little earlier, is is a tools example. And in this tools example, what this will do is that it's going to go out to the to the internet, and the tool is going to search. And when it's going to search for a simple thing like the date, as an example, right? So whatever happened on that specific date. So if I go here and I say, simple web search example, give me news about cricket from yesterday, right? Now, large language model is not trained on the data about yesterday. And what this will do is that this is using another API called Tivoli, and it's going to go in and get all the information about perfect PCB and VCCI and their fight over the venue. And you can see how passionate about cricket I am, right? So don't ask me a cricket question, but but what it does is that it's actually going out. It's a tool that's going out, getting the information from an API, and then making this large language model output more enhanced as well. So that's sort of like kind of brings us pretty much to the end of the demo part. And you can see that all these different options kind of give you this possibility to create applications that are infused with AI. You can be careful, remember the different elements we spoke about. But then this thing that we initially had some questions about as well is like, when do I use prompting? When do I use real-time augmentation? And when can I do tuning, etc.? So if you look at complexity from left to right, prompting is easy. A little bit more complex is RAG. It has many different approaches, like few shots, one shot. The kind of, you'll get into it. And then also what we saw in LangChain for J and Quarkus example, where you're splitting documents and all of that. And there's an interesting quote by my colleague that I work with almost every day, where we are not using tuning large language model, but we are using RAG to create changes of code from one API to another, as an example, right? So there is, if you need context specific solution, you use RAG. If you don't need much context, just basic context, you're using prompt. If you have so much of data, like an entire domain, like an insurance domain within your company, you'll go more likely for tuning, right? And that's how you would balance what you actually really need to do. Finally, these are some of the links. LangChain for J, the nice tool. So it's a library that is for Java developers. There are other frameworks that also use LangChain for J, but then the extension that I've worked with is the Quarkus LangChain for J extension that you saw the demos with today. There's also a great lab by my colleague Clement Escoffier, and he's written an entire workshop, which I provide the link here as well. And I'm going to upload these as well so you can get them later, that you can actually run through this online. And it's a very interesting, it goes into a lot more detail than I went in today's session as well. And that is pretty much it, I think, for me. So let's maybe take some questions.
All right. If you have questions, feel free to ask your question. Now is the time. Use this time. Let's. We have a few questions already. Maybe we can start from there. Okay, so this question asked not long ago, I think. So the question is, between learning how to make an LLM from scratch or using it on API level, what might be the best approach to gain more knowledge on this space? Basically, someone asked who it's a beginner friendly question mainly.
Yeah. It's a
So
very
if I were
interesting
to,
question.
yeah,
Yeah. So I think it's a very interesting question, right? So I think I sort of touched on it in a 2 slides back, I think, and that is you need to define where you're going. So if it's a simple large language model, you want to learn how to tune models, how they actually work. Then the book I mentioned, large language model from scratch. By the way, I'm reading the same book. I haven't finished all of it, and it's amazing to actually understand the inner details of a large language model, how it works, how the tokens work, how the algorithms work. But then the API part is where you are using, so it's like you build a car, and or either you drive the car. So building a car it has a lot of details, depth to it. Driving a car has a different use case, and in this case, driving a car is like API. And in the API world, you're actually infusing all that information that's in the large language model that you use, and then you can use it in your applications. I have an example. I wrote a demo application together with some of my colleagues, and what we did was that we use RAG and all of those things, but then we also trained the model with insurance data for a specific company. And in that case, yes, I need to learn some of the ways how to actually do fine tuning and training. So I would divide this in three spaces. Large language model from scratch is totally bare bones, plumbing, knowing exactly how things work and what you need to do to build one. um, Tuning is actually a bit different beast, and that's more around how you would tune the base model with your data. And then finally, the API part, which is as an app developer, for bringing more value to your applications in general and to your customers. Can you use data from your existing systems, use large language models, and mesh that data together to create awesome apps? I think that's how I would answer your question.
thank you very much. I think it's another question. It's more of a clarifying questions. You mentioned about the embedding. So what he asks is, where is the embedding factors that I will sit in? Already the model has factor, and we contract them via API. How this embedding works here?
So the embedding is what you're doing is that we have a cache or a local vector store that is basically using the embedding. So we can send this to the LLM. The LLM will generate the embeddings for us, and then we store the embeddings. One thing that maybe I did not mention is that in this presentation is that remember that large language models do not have a memory feature. You might see that on ChatGPT interface, etc., but really the large language model doesn't remember what you just gave it to it 10 seconds ago. It only remembers to respond to what it received. So in this case, when we generate the embeddings for our data, using a large language model to generate those embeddings, then we store those embeddings within our system, and once we query them, we give that embedding context to the large language model so it can process them faster with our data, basically. So that's how it works. So it's not like that the LLM would remember what your embeddings were, or it would remember your data. It doesn't remember anything, and that's the hard part for us as developers to also work with. And LangChain4j and other tools, they take care of that.
Perfect. Yeah, there is another questions, and kind of a similar question I have. So it's about security, right? How would the use case something similar to Copilot, where we can have a model built which uses legacy Java codes to train and accordingly run on Git repos and automatically handle vulnerabilities and CVEs via PR. So basically, he asks to build a copilots similar to copilots. But the question that I have, some of the training are based on old data. For example, when I use copilots or other um, AI assistant, some of the code they produce are pretty old, and some of them are not up to the mark, I would say. So how do you deal with constant change? And then also a follow-up question, maybe when we are sharing doing the embeddings and all those things, we are we sure to trust? I mean, can we trust the large language model, especially because OpenAI supposed to be open source, now it's closed source? Should I trust them?
There's a lot of questions in there, so I'll dissect it one by one, right? So first distinction that you should make is that when you go on Hugging Face as an example, you will see models that are called instruct models, there are code models, there are chat models, there are base models. There's different types of models. So the code model is specifically for coding, and it would be basically trained on data which is for coding, and it's trained in a way that it's good at generating, like for example, there are companies out there that have trained a model to generate documentation only, or trained a model that generates test cases only, right? And they're good at those use cases. So it also depends how the model is trained. The second part of the question comes is or the first part of your question comes is like, how do we know it's secure or it's old? We don't. It's like we only know that when the model was released, and what kind of data set that they used, right? And they're going out, getting almost everything public out there, and generating the large language models. And once that happens, there is going to be insecure code in there too. So when you ask an LLM to generate something for you, yes, it will have a mistake, and it can have a mistake, and it will hallucinate. And that's exactly why I said that do not mix truth, with hallucinations. Make sure that accuracy and truth are two different things that you understand, because a system could accurately give output, but not necessarily that it is the true output, right? So you need to differentiate that. And the way you differentiate, there's a couple of things you would do. You would deploy a simple tactic like, oh, well, when the output comes, I'm just going to, take that output and sanitize it and check if it doesn't do anything specific. But interestingly enough, there are already models out there. Like Llama has a model called Purple Llama. Or even if you go on ChatGPT today and ask something, it's going to sometimes give you answers like, oh, this is not in my policy, or this is not correct. I cannot answer this question. And the reason is that there's another model, like in this case, in Llama's case, Purple Llama, which will then check against, all the different factors like discrimination, bias, authenticity, etc. All of these things that you can check against before the response goes out to the end user as well. So such techniques could be deployed, but hallucination is a very, very serious problem. And imagine that if you were deploying it into a mission critical system and someone's lives were at stake and the model was hallucinating, like for example, giving prescriptions about someone's medical condition, or about caregiving in terms of taking care of someone, and they said, well, you don't need to take care, but you did need to take care at that point. So we cannot rely on large language models solely, but we can actually use them, enhance their outputs, enhance their judgment, reasoning, etc., deploy tools across it, and then actually enhance our applications. So there are ways to it, but I still think that there's a long way to deal with hallucination still. There's no big solution that can accurately define that. Did I answer all your question, or did I miss something?
No, pretty much. I think a lot of questions are flowing. I don't know how long I can keep you, but there are some questions. I hope it's let me know when you have to
Go
go.
ahead. Go
Because
ahead. I'm fine. I can do it.
all right. So there's another. I mean, I think similar questions, follow-up questions. I think about the which is basically it's saying, if we send data to the Open API, our data, it could be our business secret, right? For embedding, uh, the data is compromised. Is it the case or not?
Um, it can be. It can be the case because you're sending the data to a public system, and your data is secure. Your data most likely has security tape attached to it that you cannot share. Like for example, if you're in a big company, and like a bank or something, and you have source code that you're working with, you can't share that source code outside because it can leak things that, or even ways of your programming. So yes, there with public models there can be a situation like that.
All right. So there's another questions. Let me read it for you. In the demo, Shaf shows we are calling OpenAI API using Quarkus LangChain for JOpen AI. So we're just using their API, but can you just tell what kind of benefit bring to us as a engineer or software developers? Um,
Yeah, for sure. So basically, I'm the API is a REST API, but in the code that we are building, we are having a chat model. We are having some memory in it. We are having embeddings, document splitting. All these, there's a lot of features, vector store support. All of these need a library, and that's what LangChain for J does. Is brings you that experience so that you can use it. So it definitely is great. Would you want to use a library? I would say yes, because otherwise you'd have to plumb this and write this all from scratch. Does it help you? Yes, the use cases, there are quite a lot of use cases, like I kind of showed you, right? Simple. For example, take one of my colleagues, friends was discussing this that, hey, every time I need to go and search into my bank statement, I need to go through this really rudimentary search that takes a long time and sometimes doesn't even answer. What if I could actually use something like a large language model to make that search even more efficient? So that's a good example. The fraud detection example, I went maybe a little blazing fast on that because it was almost the end, but um, in the fraud detection example, what it also does is takes the data internally, just the amount of data that you need, and from your database, and that enhances the context with that, so that the LLM in that case is telling you there's a distance between two cities is too long. Now imagine if you had to create a system that would measure the distance between cities. Maybe, well, you could use Maps API, I guess, but still, um, you would have to handle all of that. But in this case, that can be done. So large language models have multiple use cases, like in terms of the data they host, that we can actually use them. That's one. So we should definitely use them for that data that we can get. We should be more specific on how we craft our prompts, so we can get specific answers back, and leave the hallucination to a very minimal, or not leave it to chance, I would say, like that. So there are benefits definitely that you can use within your apps, that would help you.
I can give a examples. For example, database, right? We use regularly. Although we are a Java developer, right? But we use JDBC to get the data and set the data to the database. We can think LLM as also a kind of database. As a Java developer, we will communicate with the LLMs, but do all sort of other stuff on top of it. I mean, like you have mentioned a lot of examples. So for similarly, we build product with Java. I mean, it does amazing things, all sort of variety of examples here. But end of the day, it is stored data in database, plain text, simple, just splits our objects into data. So similarly, we can have that kind of thought process. So LLMS is there. We can use it as a tool, and then based on top of it, we can build all sort of applications. Um, Okay. There are, and I think we have another questions related to. Oh, it's a comment rather. I think what he says. Samsung data was exposed due to the ChatGPT after employees accidentally uploaded sensitive information to their platform. So this can happen. So you gotta be careful.
Yes.
All right. So I think there is another questions. Uh, Well, okay, so I'll take two more questions after this, and then we'll have to finish because we don't have all day. Yeah, but yeah, we really appreciate that you guys are engaging, asking questions, and that's amazing.
Yeah,
Now
and
that
reach out and ask more questions after the session. I'm happy to answer. Yeah.
yes, I'll share the handles of shops of social medias, LinkedIn, Blue Sky, even Twitter. Now that we're using ChatGPT a lot for coding, personally, sometimes I feel like cheating. In your opinion, where is the balance between AI to do the work and doing the work by ourselves?
So, I mean, I'll give you a personal example, which I maybe is maybe a good or bad example. But I was trying to create a chatbot. I'm a really bad front end developer, and I started to use some of the large language models to give me some answers and help me because I don't understand. And it started making big mistakes, right? And that's very common. Like, models will make big mistakes. But I'll also say like this, that I was learning a bit about fine tuning and I had some issues with a certain topic. So I asked large language model to give me an answer. And when it gave me the answer, I was able to ask more questions based on specific terms that were used. So it's a great way to learn. It's a great way to explain, and it's a great way to start. Learning new technology, as an example, with code, etc. But I don't think it goes past after a while, because when your logic and complexity comes into it, then it starts becoming difficult. It's not really good at wiring, at least in my opinion. And it's not really good at design and architecture in that sense. It can probably give you a Java file representation of Spring and convert that into Quarkus, and that might just work. But when you will start to say, hey, let's do domain driven design, it's probably just gonna move back and say, okay, I don't know what you're talking about. So I mean, it might say it knows what you're talking about, but it won't be able to handle the complexity. So I think that it's good that it gives you productivity in many ways. I have learned a couple of new things in JavaScript, as an example, using large language models. But then when it gets more complex, it is not able to give answers because inherently doesn't have memory, as an example, and other things. So yes, use them, but only to the point where they are useful.
Yeah, that makes sense. And sometimes you got to do some repetitive work. For example, the benefit that I take personally, let's say I need to write these test cases, and there are so much repetitive elements in there. So I give them a pattern. This is the thing I want. Can you repeat this process like 5 times for me? Or I have a JSON schema. Can you create an object out of it? And I can just from the corporate I can just copy paste over here. Uh, Obviously I have to be very careful about what it produces and then check, verify. But it certainly helps minimize my keystroke, so I can do. I mean, typing is not that faster. I mean, as a human, I mean, our
Yeah.
input output is not faster, although we think faster in many ways, in many cases. But yeah, machine can do some things way faster. All right. So
Yeah.
there's another question. I'm going fast because we have few questions already. One
Sure.
is the question is there any Java community, Java good community for LLMs, basically. For other language, Python and other language has a good community for LLMs specifically. Is there?
I
Um,
think for Java, LangChain for J is a really good community. There's a lot of contributors, and I mean, it's amazing. And I like LangChain for J. That's my personal preference. It's also because they were like the first mover, starting to kind of produce this for all of us. They did an awesome job. And there's so many contributors that, all these extensions to these different large language models, vector data stores, splitting of documents. And sometimes the Python community and other communities can, kind of confuse LangChain for J as an equivalent of LangChain. That's not true. LangChain for J is totally something of its own. It is yes, it's inspired by LangChain, but it's not like exactly one to one. It has a lot more for Java developer in there. So I would say, I mean, that's the community I would suggest you should hang out with, and you get a lot of knowledge, and probably you can contribute as well.
okay, so this is going to be our final question. I'm going to go over quickly. What he asks is, has the recent interview landscape for software developer anyway got impacted anyway? Like now that everyone has AI assistants like ChatGPT, Gemini, and Claude. So I think there is a related question. I mean, how it impacted the job market? Maybe more specific questions.
It hasn't impacted too much. I think, like I said, it's still on the hype cycle. It will definitely be a good tool to know and work with. You can generate things, you can check things once they're generated, especially when it's code, right? So let's say if you created a tool that generated a specific code, you can run a linter through it, you can run it through a compilation process, etc. So there are ways to check before you actually even do something. So there are use cases where it's very interesting. Some of the use cases we already mentioned. So I think right now it's at a hype circle. So things are changing rapidly, but we will see more in the job market as we move on, as the industry also matures and gets more settled. I'm excited about it. I put this nice statement by Terry Orlick as well. He's actually a sports psychologist, so it doesn't really match the technology, but very interesting quote. And I think it is like when something is new, it's challenging you, it's giving you this new sense of passion. So try it, learn it, and I think in the job market, it's also going to be quite nice. If you talk about large language models in terms of the internals of large language models, fine tuning, and yeah, they're growing. A lot of different enterprises around the world are actually using large language models internally, trying to create solutions with large language models. There are companies that are creating entire verticals of it. There are companies that are creating agentic based workflows to actually create value out of it. Is it going to take your job? I don't think so. Or our job? I don't think so. It's going to help us to be more efficient, I think, and give us way more possibilities. So I think it's a good technology to learn. And yes, there is another opportunity where you can write your own tool for interviews using AI. So funny enough, I saw a demo of a tool where somebody just pasted the JD into the UI, and then it would ask them the questions around that. So people are already kind of building solutions like that.
All right. I definitely I wanted to end this with this question, but I have got another. I think let's take 30 seconds to answer that.
Sure.
Java is mature enough to use AI over Python. Now we have Spring AI, Olama, LangChain for J, and basically what is asking, if we talk about support, how it is compared to Python, where AI tools and library were introduced long before Java. I don't think that's true statement, but yeah, I want your opinion.
So obviously, I think don't mix two things. I think one is that there is the predictive AI where you're creating, supervised, unsupervised learning classification algorithms. They are very heavily used with Java, with Python, not with Java. Historically, PyTorch, Scikit, TensorFlow, these are the libraries that you would do for doing, deep learning kind of things. So don't mix them with Java. That is one part of machine learning. The large language model is another, where you're developing applications with large language models. With a predictive model, you just have a gRPC API, REST API that you just work with, right? Because whatever the model could be, as an example, simple thing, looking at destabilization of the environment as an example. So it will give you some data only about the environment in that specific case. Large language models have a lot more data into them. And what we're saying is that when you're working with the APIs, it doesn't have to be just Python. It can be with Java too, and it's really good with Java. So this is the part where I don't think this is language specific. This part of large language model is language agnostic. And whoever has a good language features and libraries to absorb that API and express it in a different way will be the winner in this. And I think that's why Java is awesome for this kind of workload. And then LangChain for J is one library. LangGraph is a new library, quite not so new, but it's also there. There's also Spring AI. So Spring AI is going towards a different tangent. But if you look at Micronaut as an example, they just released support for LangChain for J. And LangChain for J, you can also use in Spring, you can use in Halide, and all these different, or even in Jakarta as well. I know that our host here is also working on something similar on that end, right? So I would say that LangChain for J is, I would like, that's a good community, and that's a good way for Java developers to work with large language models only.
All right. Thank you very much. It was wonderful having you, and we have learned a lot. Personally, I gained a lot of benefits from these talks. I can derive. I learned a lot. Let's put that simply. So, final question for me: how far we are from the Skynet?
From what?
Skynet.
Oh, we are way far, I think. When you have hallucinations and mistakes, I mean, other people might think differently. One of the issues with large language model is context. I know that there's research done to increase the context so we can have more tokens. There's a long way, I think, but with every artificial intelligence, when you put in, you have to put the right checks and balances. Imagine like you're putting one large language model to generate, you're putting one another large language model to check that it's correct. So I think we have a long way to go in this domain
So
to get
there's
to Skynet.
still
But that's my
the doom.
personal opinion. And let's just say that this is just a comic answer, right? So Skynet is not happening.
So the doomsday is not that near. I mean, it
It depends
anyway.
on how many movies you have watched or are gonna watch of Terminator. So
All right, thank you, Shaf. It was really, it was privilege to have you on this session. I think we had a huge audience today. I counted a lot of people's. In fact, interestingly, a lot of people watched this session from Twitter. X. I shouldn't say Twitter anymore. I didn't anticipate that. But yeah, it's fantastic to see a lot of people coming from various parts of the world, not just from the Bangladesh. So that's awesome, and thank you very much. I have an
thank
announcement to make from Java User Group. I'll do it in a quick, minute. Yeah, then I'll end the session basically. So let me share my screen quickly, if I can. So I hope you can see a website. So we're having a conference in Bangladesh. It's our 10th editions, and this is going to be a in-person events, half a day events, and we have a, fantastic speaker lineup. So it's going to we have the conference is going to be in 21st December, so it's not that far from us. So we're going to share the details. Keep an eye on this website. Everything will be over here. And if you're interested, to give a talk, there's a link over here. You can press, which is basically give you the sessionized website where you can submit your talk. So all the details are available over here. And this is the website. We will get all the details over here. We don't have anything yet. It's still in progress. We are making it. The volunteers are really putting effort to make this website and arranging all the other stuff. It was in a bit of hurry. We sort of decided that we are going to have this conference in last month. We have been discussing for a long while, but everything's come to in a what do we say? Decision were made last month. So we have similar events in past. So we have some featured speaker in past. You can see that. But most importantly now, what is important for us right now is to have you submit a talk if you are interested in this in-person event. All the details will be over here. And we'd like to thank our sponsor. This is our local company, Salis. They're sponsoring the entire event, all the logistics and everything. I definitely want to thank them. And yeah, this is going to be our venue. You'll find everything over here. And this is our esteemed team. All they are working hard to make. I'm here. I live in Toronto. I don't do as much they do. So thank you very much, everyone, for putting all this effort. All of you have a day job, and then on top of that you are working for this event and everything. So yeah, thank you very much. So this was my announcement. You will find all this information in our JAGBD website. So if you go to the JAGBD org, you'll see you'll find everything over here, and I'm going to write a I'll put everything over here. So basically, this is a one place, a one-stop place, and the website is jdc.jagbidi.org, and there's a QR code over here. If you want to, you know, take this will get you to the website. You just scan this QR code from your phone, so everything will be there. So thank you everyone again for joining for this session. It was wonderful. I learned a lot. I can't thank enough for having this session. Shaf, thank you again. Hope
Thank
we'll meet
you. It was
again
a
in
pleasure.
person someday in Copenhagen, or you visit us in Toronto or Bangladesh maybe.
Definitely. No, thank you. This was an honor to present, and a lot of good questions. So feel free to reach out and ask questions. I'd be happy to answer. Thanks
So
again.
let me share your blue you are I think you moved to blue sky pretty much. I can see that. So this is your handle. If you go to this profile sharp.dev, you will find him, and you can ask questions directly. Also, I mean, LinkedIn, you can also reach out to him through LinkedIn, and you can start conversation of the event that we created in the LinkedIn. So that would be a nice place also asking questions for follow-up questions. And this video will be available everywhere, YouTube and LinkedIn, so you can rewatch again to get more in, I mean, if you forget uh, some of this stuff. And I'm going to share all the slides and related content with you. Yeah, so thank you everyone. It was a lot of people say thank to you.
You're
So
welcome.
we're gonna end now. Thank you again everyone.